Hi friends, welcome to KPB Coding Hub. In this video, I'm going to explain one Java new feature which is released in Java 10. In Java 10 version, there is a one new feature is there. So what is that feature is local variable local variable type inference. Okay, inference. So we have this new feature which came in Java 10 version. What is the name of this concept? Local variable type inference. So what is this concept? See, up to Java 9 version, if we want to declare any variable, if we want to declare any variable, how we are going to declare? Just integer followed by some variable name x is equal to some value like sir 104. So what is the meaning of this? We are assigning an integer value to the variable x and it is of type integer. So this is nothing but valid up to Java 9, up to Java 9. So but from Java 10 onwards, the same statement you can take like this. Same statement you can take like this from Java 10 onwards. What is the meaning of this? Instead of declaring the variable type, you can mention with variable var on right hand side which value you are assigning. Based on that, the type of the x is going to be considered automatically. So this is one of the new feature which came in Java 10. Okay, in Java 10 we have this feature. So anyway, I'm going to demonstrate this feature with the help of examples. Multiple examples I will cover. So before that, let me add the document. So Java 10 introduced VAR. I can't say it is a keyword, just VAR. So far, local variable type inference. Okay. So allowing the compiler to infer the type of the VAR automatically. So automatically based on the assigned value. Based on the assigned value, it is going to consider automatically. Okay. So what is the advantage of this feature? Sir, this feature, okay, the main advantage is nothing but, so this feature makes the code cleaner. So by reducing, okay, by reducing redundancy, okay, by reducing redundancy, you are going to clean up the code. Okay, very short code we can able to write. So anyway, I think the concept of this VAR is very clear for you. I will take multiple examples to demonstrate this VAR keyword. Okay, multiple examples I am going to demonstrate for this. Let us take example number 1. What is this example is, I'm taking some simple Java statements to make very clear understanding. I'm taking some simple Java statement and I will execute the code. I will show you whether this VAR is working or not. So I'm taking my Java program, a simple Java program with a file name as a test.java. So now I'm going to declare like integer x is equal to 111. And I'm taking some floating point variable. Some floating point variable is equal to, or let me take double. So double y is equal to 34.567. And I'm taking one string variable z is equal to something like Prakash. Like this I have taken. And I want to print all these variables like x, y, and then z. So what is the conclusion that I told? You can replace this integer with var. You can replace this double with var. you can replace this Z with VAR. Let me check whether this code is valid or not. So I think in my system already I have Java latest version. Okay. So, but I want to show you in Java 8 version how it is going to work. I changed the path to Java 8. Let us compile this program and see whether we are getting error or not. You can see cannot find symbol var. Have you observed the class variable is not there, like that it is telling. So can I say it is invalid in Java 1.8? Now I'm going to change this. So to Java latest version, which is nothing but a 22. I shifted to Java 22. Now try to compile this program and check whether it is working. Perfectly working. Let us execute. Are you seeing? We are getting 111, 34.567, and then Prakash. So by using this VAR keyword, if you declare any variables based on the assigned value, automatically the type is going to consider. This concept is called as what? Local variable type inference. And this concept came in which version? Java 10. So I think you got very clear clarity about this. Okay. Hope example 1 is very clear. So just to pause this video for 1 or 2 minutes and try to execute this program in your system, sir. Okay. Now I'm going for the second example. What is the second example is it is very common requirement, sir. In for loop or in for each loop, in for or, so for each loop, in for or, so for each loop, we will always use local variable, right? In that place also, can I take var keyword? Yes. Suppose for integer I is equal to 1, I less than or equal to 5, I plus plus, I want to print a message like KPB coding hub, something like this I want to print. How many times we are trying to print? 5 times. So what type of variable I is integer? Can I replace this int with var? Yes, it is allowed from Java 10 onwards. So it is holding what type of value? Integer values. During execution, what type of value we assigned for I, based on that type will be considered. If you want, you can check the program is going to compile fine, and even if you execute, we will get output from KPB coding hub. How many value, how many times it is printing? 5 times it is printing. I think the second example, which is related to for each loop, is also very clear. So try to execute this program from your end and check whether it is working or not. Okay. Now, so I want to take third example. Slowly the complexity of these examples are increasing. I want to use the concept of arrays. How to use this VAR, variable inference, so for arrays. Generally, how we are going to declare the arrays, sir? We know very well. We are going to take like integer a is equal to. Can I declare 1, comma 2, comma 3, comma 4, comma 5? How to print? For each item, so present in this array, try to print that item. Like that we will take, right? So let us compile. Is it compiling fine? Yes. But sir, can I replace this integer with var? No, sir. If you are trying to take, you can see var is not allowed as an element type of an array. Sir, for arrays, you can't use this. For arrays, you can't use this. So this line is invalid. Sir, then how to define for arrays? Very simple. var a is equal to, already we know how to create nameless arrays. In that style, we need to take, sir. Just for easy understanding purpose, I am changing the elements. Now we are declaring a variable a, which is holding integer array one dimensional. And these are nothing but the elements what we have. Sir, even in for each loop also, Can I replace this with VAR? No problem. If I compile, the program is going to compile fine. If you execute, the output what we are getting is, you can see all the values it is printing as it is. All the values it is printing as it is. This is nothing but what we have. I think it is making sense for you people. So whenever you are applying this VAR for the arrays, please remember the syntax. We have to use this nameless arrays concept and apply. Okay. Try to practice this example also from your end. Now, example number 4. Sir, can I apply this VAR for collections? Yes, sir. For collections, we can do. Okay. For collections with a homogeneous, for homogeneous values or for homogeneous objects, I'm trying to apply this VAR keyword. Sir, is it applicable for collections also? Yes, we can take. I am declaring one collection called list is equal to what type of values it is going to hold. I am taking array list. Sir, I am going to hold what type of objects? String objects I am holding. Because we are working with the collections, compulsory we have to import which package? Util package. Compulsory we have to import util package. And we have a list which is holding these string objects. Sir, can I add the objects? How to add? By using add method, I am adding. So triple A I am adding. Next and after that I am adding triple B. Next and after that I am adding triple C. Now try to print that list so that we will check whether this VAR concept we can apply for collections or not. Now try to compile the program. The program is going to compile fine. Try to execute the program. You can see the output what we are getting is triple A, triple B, triple C, like we are getting. So I hope this example is also very clear for you. Okay. So I think you can pause this video and practice this. Okay. Right, sir? Now, same example, sir. Is it possible to hold heterogeneous objects? This is important question for interviews also. Why? Because, sir, how you are going to mention heterogeneous? Sir, here you are taking string. If you are not taking anything, automatically it will take heterogeneous. Now try to insert one new integer object, and try to add one string buffer object and see what will happen in this case. Sir, is it accepting? No, you can see, sir, we are getting some two error messages. Forget about warning, two error messages. Incompatible types, integer cannot be converted to string, string buffer cannot be converted to string. Sir, why? Because you mentioned that it is going to hold only string type. If you remove this operator is diamond operator. If you remove this, which type of objects it is going to allow? It will allow heterogeneous objects, and you can see that integer also get added and that string buffer also get added. Forget about these warning messages, we can ignore. So the conclusion is we can use VAR, variable type inference variable, even for collections also. This is nothing but the fifth example what we have. I think these five examples are basic examples what we have. Okay, I think it is very clear for you guys. Now I want to take sixth example, like it is a conclusion. It is one special case I am going to cover. Sir, in the interview, especially in multiple choice questions, there may be a chance of getting question like this. Variable x is equal to 999, and if you are trying to print x, we will get a 999. Sir, can I take here also VAR? Okay. Can I take here also VAR and check what will happen? Sir, is it going to raise any error or not? Let me check. Sir, successfully the code is compiling. If you run, what will happen? If you run, what will happen? We are getting 999. Sir, the code is perfectly working. The code is perfectly working. So we can take VAR as an identifier because it is not a keyword. That point I am trying to highlight. It is not a keyword. VAR is not a keyword. If you want, let me add here. So VAR is not a keyword. Is not a keyword. Okay. So I hope it is making sense. Next, another example, sir. So example number 7. I want to apply for the collection, but we have seen for collections example as a array list. Can I use this for map? For map objects, is this VAR is applicable? Yes. Let me try one example. Sir, I am taking VAR, some map is equal to, I am declaring a new hash map. I am declaring a new hash map where key is nothing but integer and the value is nothing but string type. Like this I am taking. Okay. So I want to print that map. How to add the objects? Map dot put off. So key is triple one and the value is nothing but, so let us take Prakash. So key is nothing but triple two and the value is nothing but Kalyan. Let me check up to this. Perfectly validating. You can see anyway, insertion order is not preserved, right? Triple two Kalyan, triple one Prakash. Sir, you can represent this entire thing with a type inference also, no problem. So it is applicable for map objects also. There is no issue. I'm trying to explain all possible combinations. Sir, next three are very, very important. Please observe carefully. Example number 8. What is this example is, sir, can't we apply for streams? Can't we apply for streams in Java 8? We have streams concept is there, right? Sir, can't we apply for that streams also? Yes, happily we can apply. Sir, if you apply for streams, what output we are going to get, that part we will clear now. Okay. Suppose consider I am taking one variable VAR. Okay, VAR. Let us take names. I have some names are there like list dot of I am taking. You can see this is nothing but just to convert the given objects into list format. Sir, I am taking some names. Okay, like Prakash. Okay, so second name is nothing but Arun. Okay, so next I am taking something like Bobby, and next one is nothing but some Akash. Okay, so next one is something like Charlie. Okay, so next something like Tarak. Like this, I have some names. My requirement is I want to filter the names. So what filtration I want to do? Sir, filtered. Okay, otherwise F names, filtered names. So how I want to filter? Sir, on these names, I'm going to call stream function. So what will happen? Sir, it is ready to process. It is ready to process. So on this stream, so I'm going to call filter method. Sir, how you are going to filter? For for each name present in the names, I will check is it starting with capital A? Sir, what this filter is going to do? In these names, if any name starts with A, such type of values it will filter. Sir, from that, can you collect all the result whatever you got? So collectors dot to list. I am converting into list. That's all, sir. So what will happen? It is going to take these names from the list into stream. From that, we are filtering by using this lambda expression. What is this lambda expression? Lambda function. It is taking name as the parameter and it is checking whether it is starting with A or not. From that, we are collecting all the values and try to print first names and try to print the filtered names. Both I am trying to print and you can see the difference what we are going to get. Sir, the program is compiled fine. Variable collectors. Sir, C is nothing but any spelling mistake. Ah, sir, you have to import stream for this. You have to import stream for this because in stream that collectors is there. Now the code compiles fine and it is running fine. And you can see, sir, we have original names Prakash, Arun, Bobby, Akash, Charlie, Tarak. But which names got filtered? Arun and then Akash. Like that we have. So this is nothing but we can apply this type inference even for streams also. Sir, if you are taking not of this one, what will happen? Sir, is the code is going to compile fine? Yes. If you run, except the names starting with A, remaining things are coming. Okay, anyway, in our videos, we are going to upload these. Already you can see in our channel, we have these lambda expression, multiple examples are there. You can go through that. So this is nothing but what we have another example. Hope it is making sense. This program compulsory you have to practice. Sir, next example, I want to take I want to take this type inference even for anonymous classes. Sir, nameless classes are there, right? Can I apply this for nameless classes? Yes, happily you can apply. If you want, you can see how it is going to work. Sir, I am going to declare a variable called runnable. Runnable. So you can see I'm creating one object for runnable interface. Runnable interface. So can I declare like this? Yes. Sir, without any name, I'm creating a nameless class. And inside this runnable, we have only one method is there. We have to override that method. What is that method? Public void run method is there. Public void run method is there. Okay. So it is overriding. It is overriding. Okay. Public void run method is there. And it is printing some simple message like let me print. So running something like this I am taking. That's all. Sir, I declared one object called runnable. So for which class runnable interface, I implemented that class and I have. Now how to call runnable dot, can I call run method directly? Yes. So just I created a nameless object and you can call that. So this type reference variable is applicable even for nameless classes also. No problem. Hope it is making sense for you people, right? Now, so the last example for this, sir, can I apply this can I apply this for lambda expressions? Yes, happily you can apply this for lambda expression also. Let us see how I'm going to apply for lambda expressions. Okay. Now, to apply these lambda expressions, we need a functional interface. That's why I'm going to include function also. Now see how I am going to apply this. First, I am going to take a list which is capable of holding string objects. Let us consider names and I am taking arrays dot as a list. I am going to provide the names. What are the names that I have? Let us assume, so Kalyan, and I am taking Prakash, and I am taking Raju, okay, and I am taking Somu, and I am taking James. Like that, we have certain names are there. So let us take all the names in lowercase letters because I will convert these into uppercase by using this lambda expression. I will do. Okay, let us see. Sir, first input is ready. Now I am taking VAR greeting, or let me take wish. Let me take wish. It is a method. It is a method. Sir, what this method is going to do? Sir, we are going to write lambda expression. So what is the parameter I am taking here is, for this I am going to use consumer class. In the consumer, it is taking what type of object? String object. And let us name that one as nothing but what? MSG message. It will take this parameter and I am trying to convert some message. For example, good evening, good evening. So followed by some space or comma, I want to print that name or I want to print that message. Message is nothing but what? Whatever argument that you are getting, you will print as it is. Okay, so I'm going to wish this. This is nothing but lambda expression. For each variable present inside names, I want to call wish dot. There is one method is there, right, in consumer class. What is that method? Accept. Just I am passing that name. For each and every name present in these names, I am passing to which method? Accept. This accept method is defined in consumer class. What type of argument it is taking? So it is taking string, and that message will be printed with this functional interface. Now let us execute this program and see what is happening. For every person, we are going to get the wish. Have you observed how beautifully we implemented? The first line is nothing but input, list of names. Second line is nothing but we created one lambda expression. Third one, we are calling that lambda expression for every parameter. Like that, we can able to use so type inference even for lambda expressions. I hope this example, these 10 examples is making very clear understanding of this VAR, how you can able to use. And there are some conclusions. There are some 4 or 5 conclusions are there. Let me cover with that. I will stop. Okay. Now, note number 1. What is the first note? Sir, it is applicable. It is applicable. Okay. I can say disadvantages. It is applicable only for local variables. It is applicable only for local variables. Sir, I can't use for class variables and all. Suppose consider I have a class is there. Okay, so I have a class is there with name A, with name A. Can I declare integer I? Yes, you can declare. There is no problem. The code is valid. Sir, can I take so VA or J? No, sir, because you can see what message we are getting. VAR is not allowed here. You can't take for instance variables. You can't take for instance variables. That is nothing but the first conclusion. Note number 2. Sir, it is not applicable. It is not applicable for, it is not applicable for constructors and method parameters also. Sir, what will happen? Assume I am defining one method like integer I am taking, like this I am defining. Sir, is it valid? Yes. In the place of this int, can I take var and see what will happen? Sir, var is not allowed here. So that's why it is applicable only for local variables, not for constructors and instance variable. And one more thing, note number 3. Sir, now let us see in main method. In main method, so what I am doing is I am declaring var x is equal to something like 12.34. So var y is equal to, okay, I am trying to take integer of x. Integer of x. Now see what will happen. The code compiles fine and try to print the value of x and the value of y and see what will happen. Sorry, Java C. So test.java, Java space test. What output we are getting? 12.34 and 12. Have you observed? Is typecasting is allowed or not? Yes. So typecasting is allowed for, okay. So variable, local variable. So inference, local variable inference. Okay. It is valid and this is nothing but output what we are getting. So what is a note number 4? Note number 4. Sir, here if you take, um, we can't we can't declare like this. If I'm trying to take empty declaration, what will happen? We will get error. Cannot infer the type for local variable x. Cannot use var variable without initializer. Sir, I can say initialization. Okay. So initialization is mandatory for variables, VAR. Okay, VAR type inference. Compulsory, we have to declare initializations. Without initialization, if you are trying to take, then what will happen? We will get error. Last note, which is very, very important. Sir, here we cannot assign null values. Sir, it is applicable for objects, but you can't assign null values. Okay, if you are trying to assign null values, we are getting same, cannot infer type for local variable X. So variable initializer is null. You can't initialize null values. This is nothing but the new feature which came in Java 10. What is that feature? Sir, what is that feature? Local variable type inference. So total, I covered 10 examples and 5 important conclusions related to this. Try to watch this video one more time and parallelly practice in your system by installing latest version of Java, which is greater than or equal to Java 10. Okay, try to execute and check whether it is working or not. Okay, right, sir. Thank you. And please share this video for all students. Okay, and your friends also. Okay, share the knowledge. Okay, right, guys. Thank you.